And one more function, that is bijective function. What is a bijective function? See, bijective function is if a function is 1, 1 and 2 on 2. Okay, both 1, 1 and 2 on 2, then it is called a bijective function. Okay, if a function f is 1, 1 and on 2, then it is called a bijective function. Okay, so let us take one example. So example is, okay, let us prove one problem. Okay, prove that the function f from q to q, okay, that is rational numbers to rational numbers, given by f of x is equal to 2x minus 3 for all x belongs to q, okay, is a bijection. It is our question. Okay, it is our question. That is, prove that the function f from q to q given by f of x is equal to 2x minus 3 for all x belongs to q, that is, all x means these all elements are in q, that is in domain, okay, is given by f of x. Function is defined as f of x is equal to 2x minus 3 for all x belongs to q is a bijection. What we have to prove? Given function is a bijection. For bijection, we have to prove given function is 1, 1 and 2. Okay. So first let us prove 1, 1. See, given function is f of x is equal to 2x minus 3. Okay. What is the method to prove 1, 1? See, if f of x1 is equal to f of x2, that implies x1 is equal to x2. Okay. So here first we will take f of x1 is equal to f of x2. What we have to prove? X1 is equal to x2. F of x1 is equal to f of x2 implies, see here, f of x is 2x minus 3. So f of x1 is 2x1 minus 3. That is equal to 2x2 minus 3. Okay. Here minus 3 cancelled. So 2x1 minus 2x2 is equal to 0. 2 is common in both sides, so both the terms, so take 2 outside and take right side, so it will be 0. So it will become, okay, I will write one more step. 2 into x1 minus x2, 2 is common, right? Okay, that is equal to 0. This implies take 2 right side, so it will be 0. That implies x1 minus x2 is equal to 0. That implies x1 is equal to x2. Isn't it? So here we have got x1 is equal to x2 when we have taken x1, f of x1 is equal to f of x2. So if f of x1 is equal to f of x2 implies x1 is equal to x2 in this function, therefore given function is 1, 1. Okay, given function is 1, 1. Therefore f is 1, 1 function. Okay, next for bijection, right? We have to prove given function is bijection. We know that what is bijective function? Bijective function is 1, 1 and 2 on 2. Okay, we have proved given function is 1, 1 and next we have to prove given function is on 2. Okay, so what is an on 2 function? Every elements of codomain. Every elements of codomain has one pre-image in domain. Okay. Now, how to prove? Okay. See, what is our function? F of x is equal to 2x minus 3, right? See here, let us take f of x is equal to y. That is one element from this y is in codomain and y is an element of a codomain. Okay. Now we have to prove this element has pre-image. Okay. F of x is equal to y. Now substitute here f of x is equal to y. So y is equal to 2x minus 3. Okay. That is, so this implies, okay. So here take y here, 2x here, okay, y take minus 3 here. So y plus 3 is equal to 2x. This implies x is equal to y plus 3 by 2. Okay, taking 2 here. So we will get x is equal to y plus 3 by 2. Now, okay, see here, what is x? See, x is the image of, pre-image of y. Okay, is it exist? That we have to prove. That we have to check. Okay, x is equal to y plus 3 by 2. See, what is our function? Function f from rational numbers to rational numbers, right? See, when we substitute any number, okay, any rational number here, okay, we will get one rational number, okay, that is x. Okay, so here x exists. Okay, so we can write f of x is equal to y. Okay, this y is an element of a codomain and it has a pre-image, right? That is x. Okay, that is y plus 3 by 2 is the pre-image of y. Okay, so this element of a codomain has a pre-image, that is y plus 3 by 2, that is x. Okay, therefore we can say this given function is an onto function. Okay, understood? See, first what we took here, f of x is equal to y. Okay, that is y is an element of a codomain. Okay, and here we have to prove this x is exist. Okay, in domain. Okay, that is f of x is equal to y, means y is equal to 2x minus 3 substituted here given function, and y plus 3 is equal to 2x. Okay, and derivation from derivation, y plus 3 is equal to 2x, x is equal to y plus 3 by 2. Okay, so this y plus 3 by 2 is in domain. Why? Because if we substitute any number here in y, we will get one rational number, right? That is in domain. Okay, so here we can say every element in domain has pre-image in every element in codomain has pre-image in domain. Okay, therefore it has one pre-image, right? Therefore given function f is onto function. So given function is 1 1 and onto function, hence f is bijective. Okay, understood? Now let's go through some questions of functions. Okay, first question, the relation f is defined by f of x is equal to x square 0 less than or equal to x less than or equal to 3, 3x 3 less than or equal to x less than or equal to 10. Another function, relation g is defined by g of x is equal to x square 0 less than or equal to x less than or equal to 2, 3x 2 less than or equal to x less than or equal to 10. So here our question is, check whether f and g are functions or not. Okay, let's check. See, the given function f of x is equal to x square when 0 less than or equal to x less than or equal to 3. See here x values are domain, right? Means elements of domain. So here let us take one element from domain, that is x value. X is equal to 3. Okay, so when x is equal to 3, what is the function value? Means f of 3. F of 3 is nothing but 9, right? So here let us take 3. See, when x square, okay, when 0 less than or equal to x less than or equal to 3, the function is x square. When 3 less than or equal to x less than or equal to 10, the function is 3x. Okay, so let us take one element from here. Okay, so that is 3. So what is f of 3? Here also f of 3 is 3 into 3, that is 9. So here we can see every element of domain has only one image. Okay, that is the definition of function, right? Every element of domain should be exactly one image in codomain, right? So here it is satisfied, right? So given function f of x is a function. Okay, given relation, f of x is a function. Now what about g of x? The relation is x square when 0 less than or equal to x less than or equal to 2. Okay, 3x when 2 less than or equal to x less than or equal to 10. Okay, here also let us do the same method. Okay, so here first let us take one element from domain, that is x value, x is equal to 2. Okay, so what is g of 2? G of 2 is nothing but 2 square 4, right? Take one element from here, that is g of 2 is equal to, here 3 into 2, that is 6. See here, the element, okay, from domain 2, okay, element 2 has two images, that is 4 and 6, okay. So it's not a function. Okay, what is the function definition? Every element of domain should be only exactly one image, right? So here element 2 has two images, therefore given relation g of x is not a function. It's not a function. F of x is a function. Okay. Next question, find the domain and range of the real valued function defined by f of x is equal to square root of x minus 1. See, what is the real valued function? The function is about only real values, means real numbers. Okay, that is the real valued function. So here our given function is f of x is equal to square root of x minus 1. Okay, so here we can say that the function is defined when only if x minus 1 greater than or equal to 0, right? Why? Because if x minus 1 less than 0, that is negative values, square root of minus, that is not real numbers, right? That is a complex numbers. So this here it is given that real valued function, that is functions containing domain or codomain. Domain and codomain have only real numbers. Okay. So here the function, given function is defined only if x minus 1 greater than or equal to 0. So f of x is defined only if x minus 1 greater than or equal to 0. X minus 1 greater than or equal to 0 means x greater than or equal to 1, isn't it? So here the function is defined only when x greater than or equal to 1. So what is the domain? Domain means all the elements of all the elements of first set, right? So x values. So what is the domain? Domain is nothing but here, see, less than x greater than or equal to 1. So the elements are starting from 1, okay, so or equal to 1. So 1 is including, so closed bracket, 1 to infinity. Okay, 1 to infinity. So it is the domain. Okay, and here it is the, these are x values. Okay, now let us find what is f of x. See here, what is the range? See, we know that f of x is greater than or equal to 0, right? F of x greater than or equal to 0. That means square root of x minus 1 greater than or equal to 0. Okay, no need to write this one. F of x greater than or equal to 0 means range, right? Range are greater than or equal to 0. So what is the range? How to write range? Range is nothing but close bracket 0 to infinity. Okay, so it is the range. Okay, next third one. Find the domain and range of the function f of x is equal to x plus 1 divided by x minus 2. Here also same question. Find the domain and range of the given function. Okay. So the given function is x plus 1 divided by x minus 2. Okay. So here the function is defined only if, see, if x is equal to 2, the function will not be defined, right? See, it is undefined because x is equal to 2 means denominator will be 0. If denominator is 0, it is not defined. Okay. So here the function is defined, f of x is defined only, okay, no need to write to this one. So directly we can write the domain. Okay, domain is nothing but minus infinity to infinity except 2. Okay, that is real numbers. Okay, domain is equal to minus infinity to infinity, or you can write R. Okay, set of real numbers R except 2. Okay, R minus 2. Okay, if x is equal to 2, it will not be defined. Okay, therefore domain is set of real numbers minus 2. So, okay, and except 2, in all the real numbers this function will be defined. Okay, so what will be the range? Let's see here. Let us take f of x as y. Okay, y is equal to x plus 1 divided by x minus 2. Okay, let us simplify this one. Here xy, okay, take this x minus 2 left side, xy minus 2y is equal to x plus 1. Okay, then take this x here. So xy minus x minus 2y is equal to 1. Okay, take x terms together. Okay, take x common. X into y minus 1 is equal to minus 2y is equal to 1. Okay, that is x into y minus 1 is equal to, take minus 2y right side, 1 plus 2y. X is equal to 1 plus 2y divided by y minus 1. Okay, so what is x's? X's are nothing but elements of domain, right? So here we have to find the range, right? So here range means y is an element, right? Y's are elements of a range. Okay. Here, see, if y is equal to, what if y is equal to 1? See, if y is equal to 1, it will not be defined. Means there is no element, such an element. Okay. Therefore, if here range is nothing but in all elements, means in all real numbers, if you substitute all the real numbers, you will get another real number here, except 1. Okay, because if you substitute y is equal to 1, it will not be defined. Therefore, range is nothing but set of all real numbers except 1. Okay, set of all real numbers minus 1. Next question, f of x is equal to x square plus x plus 1, then find f of x plus 1. Okay, f of x is this one, find f of x plus 1. See, very simple. See, just substitute x as x plus 1. Okay, replace x as x plus 1. That is, f of x plus 1 is equal to, substitute in place of x, x plus 1. Okay, so x plus 1 whole square plus, in place of x, write x plus 1, x plus 1 plus 1. Okay, that is x square plus 2x plus 1 plus x plus 1 plus 1. That is x square plus 2x plus x plus 3x plus 1, 1 plus 1 plus 1, 3 times, so 3. So it is the answer. Okay, next question, find the domain and range of square root of 9 minus x square. We have under root should not be negative, okay, for domain. So that means 9 minus x square should be greater than or equal to 0. The function is defined only if 9 minus x square greater than or equal to 0. That implies 9 greater than or equal to x square, or x square less than or equal to 9. That implies x less than or equal to 3 or x greater than or equal to minus 3. When we substitute minus on both sides in inequality will be changed. Okay. So here, what is the domain? So domain is nothing but minus 3 to 3. Okay, minus 3 to 3. Then what is the range? See, when substitute, first let us substitute minus 3 in x. Okay, so square root of 9 minus 3 square, that is 9. Okay, 9 minus 9, 0. So when x is equal to minus 3, f of x is 0. Square root of 0, 0. Next, substitute x is equal to 0. What you will get? F of x is equal to x is equal to 0. When x is equal to 0, 9 minus 0, 9. Okay, square root of 9, 3. So it is 3. Okay. So here, when x is equal to 3, what you will get? Same thing, right? That is square root of 0, 0 itself. So range is nothing but range is equal to 0 to 3. Okay, from 0 to 3. See our next very simple question. Let f, g, two functions from R to R, okay, real valued function, be defined respectively by f of x is equal to x plus 1, g of x is equal to 2x minus 3, find f plus g, f minus g, and f divided by g. See, f plus g, that is nothing but f of x plus g of x. Okay, that is f of x is x plus 1 plus 2x minus 3. That is x plus 2x, 3x, 1 minus 3 minus 2. Okay, that's all. F minus g, f of x minus g of x, that is, what is f of x? X plus 1 minus 2x minus of, okay, minus of 2x minus 3. That is x minus 2x. Okay, first of all, let us simplify this one. X plus 1 minus 2x minus plus 3. Okay, that is x minus 2x is minus x plus 1 plus 3 plus 4. Okay, so f minus g is this one. Then what about f divided by g? F by g is nothing but f of x by g of x. That is, what is f of x? X plus 1 divided by 2x minus 3. That's all. Then what about f into g? F into g is nothing but f of x into g of x, product of two functions. That is, f of x is x plus 1 into 2x plus minus 3. That is x into 2x, 2x square, x into minus 3, minus 3x, 1 into 2x plus 2x, 1 into minus 3, minus 3, that is 2x square minus x, minus 3 plus 2, minus 1, so minus 1x minus 3. That's all.